Good morning. This is lesson 5.4, solving compound inequalities. There are two types of inequalities we'll be dealing with today. Solving inequalities that contain the word and solving inequalities that contain the word or. A compound inequality containing the word and is true only if both inequalities are true. The graph of the compound inequality containing and. So I want you to get this point. The word and means this. It means what they have in common, or another way of saying it is the intersection of the two graphs. It means intersection or what the two graphs have in common. Okay? So let's go ahead and show you what we're going to do. You're going to have two inequalities. You're going to take the first inequality and graph it on its own number line. Directly below it, you're going to graph the second inequality on its own number line. Then we are going to look for the boundary on the left and on the right, and we're going to put dotted lines through all three graphs. The last graph is going to be our solution. In order for something to be included in the solution, it must be included in both of the other graphs. Otherwise, it's not a solution. So let's just give you an example that you can think of in your mind. If the first graph had a closed circle at +1, but the second graph had an open circle at +1, our solution could no way have a closed circle because the second graph does not have one included. So my solution would have an open circle on +1. You're going to see it in a minute, so let's go ahead and do the first problem. Again, and is the intersection or what the two graphs have in common. This works for the less than symbol and less than equal to. And I went ahead and just really made it very dramatic. Less than and, meaning whenever you see a less than equal sign, you know it's the word and you know it's the intersection or what they have in common. So this is example 1 from your notes. It says graph the solution set of x is less than 2 and x is greater than or equal to -1. So step number 1, graph x is less than 2 on a number line. So x is less than 2. I've gone ahead, and what you're going to see and what I want you to do is when you draw your number lines, I want you to put the same numbers directly underneath each other. Let's line everything up and be neat about it. So x is less than 2. I've included -2, -1, 0, 1, 2, and 3. Less than 2 is an open circle on 2 to the left. Does anyone have a question on how I graph that? The second inequality is x is greater than or equal to -1. So on this number line, I'm going to put a closed circle on -1, and it includes everything to the right. Now my solution is what my two graphs will have in common. So again, I'm going to write down my numbers, okay, and I'm dotting my lines, and the reason I'm dotting these lines is these lines form the boundaries where my solution is going to fall between my leftmost and my rightmost boundary. So if you look in the first graph, -1 is included. It's also included in the second graph, but there's nothing to the left of -1. So in my solution, let's think, should we put an open circle or a closed circle, guys, on -1? A closed circle would be correct, because -1 is included in the first graph, and there's a closed circle here, so we're going to include it here. Now my rightmost boundary is +2. In the first graph, there's an open circle. In the second graph, we could see that this line or this solution is extending through positive 2. But remember, it has to be in both graphs in order for it to be part of my solution. So what type of a circle should I put on positive 2, opened or closed? Okay, and I call these solutions, when you look at them, sometimes they look like a barbell. It's just what's in between. So my solution is a closed circle on -1, an open circle on positive 2, and everything in between. Now the next part is the part that students sometimes say, can you do that again? And I'll say, absolutely. So now we are going to write our solution in set builder notation. Write solution in set builder notation. And so I'm just going to stand up for a minute and just be very dramatic about this. So if you take your left hand and you raise it and you go to the leftmost number, that's going to be what's going to go first in your set builder. So your set builder is going to be this first number here on the far left is -1. This number right here on the far right is going to go to the right spot of my set builder notation. And then my variable is going to go in the middle. Now we have fun, guys. Now we decide what our inequality symbol is going to be. So we're going to look at -1, how it compares to 0, 1, and 2. -1 is less than or equal to x because there's a closed circle on -1. Yes? And x itself, all the numbers in this, how do they compare to 2? Are they less than or less than equal to? Less than. And that is how you write your solution. So one more time, look at me. You have a left hand and a right hand. Go to your graph. The left hand number goes in the left spot. The right hand number goes in the right spot. The variable goes in the middle. If there's a closed circle, then the symbol will have a line underneath it. If it's an open circle, it will not. And in this particular case, we were talking about less than, equal to. Question, yes? I'm going to do another example. We're going to do this one together. You ready? Okay. Okay, here we go. You're going to try this one. Let me just get rid of my answers so that you can't see them. So everybody write this down. B is greater than -1, and B is less than or equal to 3. Okay, everybody has that? B is greater than -1, and B is less than or equal to 3. Okay, so let's everybody go ahead and graph. Let me just get rid of the solution, and we'll graph these together. You guys will help me. Okay. Okay. B is greater than -1. Who would like to share how they graphed that? What did you do? Yes. What kind of a circle? Opened or closed? Good job. And now maybe you understand why Mrs. Urso, when you graphed inequalities, had you graph it on the number line. Okay, the next one. B is less than or equal to 3. What kind of a circle am I going to make at 3? Yes. And which way am I going, left or right? To the left. Okay. So we've graphed both of them. You're halfway there, guys. You're almost done. So now I'm going to put in my boundaries. Remember, I'm going to put in my dotted lines. Are you with me? Yes? So my dotted lines are going to go here and here. And let me put my numbers on here. -2, -1, 0, 1, 2, 3. Okay, so my boundaries are -1 and +3. What kind of a circle am I going to put on -1, guys? Opened or closed? Opened. What kind of a circle am I going to put on +3? Opened or closed? What am I going to do in between? Shade it in. Now go ahead and be brave. Write the solution set. So write your set builders. What's the furthest left-hand number? What's the furthest right-hand number? What's your variable? It's not X, it's B. Where does B go in the? Okay, then look at -1. How does it compare with 0, 1, 2, and 3? Is it less than or less than equal to? And how do all of these numbers compare with 3? Are they less than or equal to? Outstanding. Are you with me? Was that easier than it looked? Okay. I broke it down into real baby pieces for you guys, and I think you're doing a great job. So let's go ahead and look at my next example. If my eraser will work. Those of you that are listening, I'm trying to go nice and slow, give you guys ample opportunity. The beauty is you can rewind and watch the video again and again. Okay. Okay, here's one that's a little bit more detailed. This one is -1 is less than x plus 2 is less than 3. So the first thing we have to do is we have to do what we call a rewrite, and we're going to separate it. So my first inequality will say -1 is less than x plus 2. And my second inequality will say x plus 2 is less than 3. I'm just going to erase all of this for you so we don't get ahead of ourselves. Does everyone understand what I did there? So when you have an inequality and it's not separated with the word and in between it, your first inequality will be written as -1 is less than x plus 2. The second inequality is x plus 2 is less than 3. Now we all know that when you graph an inequality, you want the variable on the left-hand side. So I'm going to rewrite this as x plus 2 is greater than -1. Are you with me? And now I'm going to solve it by subtracting 2 from each side, and I get what? X is greater than -3. And my second inequality, I'm going to subtract 2 from each side, and I get what? X is less than 1. So x is greater than -3 is going to be graphed with an open circle on -3 and everything to the right. Okay, let me just erase it, and I'll go nice and easy with you. So we have our two inequalities. We've rewritten them. Yes? Okay. So let's go nice and easy, and let's graph them. X is greater than -3. And x is less than 1. So everybody just stop for a minute and look up here. Since -3 is going to be our left-hand boundary and +1 is going to be our right-hand boundary, I always try to go one less and one more on my number line. Does that make sense? Okay. So x is greater than -3. Opened or closed, guys? An open circle on -3. And everything to the right. X is less than 1. Is an opened or closed circle on 1. Open and everything to the. Good job. And now my solution, here's my graph. Excuse me, my number line. And so now I'm going to draw my dotted lines. My dotted lines represent my boundaries. Are you with me? Okay, so I think this is pretty evident what we're going to do. What kind of a circle, guys, are we putting on -3? What kind of a circle are we putting on +1? And then what are we going to shade? Everything in. And that really does look like a barbell. Okay, if you were lifting weights. Okay, and now let's see if you guys can write the solution. See if you guys can write the solution in set builder notation. So draw your set builders. -3 goes on the left, +1 goes on the right. Your variable is x in the middle, and then determine your signs. We should be in great shape. Who has a solution for me? Anybody? In set builders, what does it say? Thank you so much.
-3 is less than x, and
Well, -3 is less than all of these numbers, which are x, and x is less than 1. -3 is less than x is less than 1 is your solution. Are you guys with me? Yes? Okay, so now I'm going to go on to part 2 of the lesson. Part 2 of the lesson is, flip the page, solving inequalities with the word or. Or. And so you've seen, everybody has either been to or seen a wedding in a movie or on a TV show, and you take your vows and you say, for richer or poorer, for better or worse, in sickness or in health, till death do us part. So I want you to think of or as a wedding union. And the word union or means everything in the first graph plus everything in the second graph. So I'm going to give you an analogy. When I got married to my husband, I had a walk-in closet full of clothes, shoes, and purses. He had hardly any clothes. He taught PE, so most of his clothes were shorts and T-shirts. He had 2 pairs of dress pants and 1 pair of dress shoes. But he had lots of toys because he coached all kinds of sports and rep. So he had footballs, basketballs, everything. So we moved out of the condo that I was renting from my parents and into the condo that he had. And now we had all of my stuff plus all of his stuff. So now everything that was mine and everything that was his became ours. And that's what it's like when we graph an inequality with the word or. So let me go ahead and do the first example with you. And so I want you to think of or as, instead of it being greater, E-R, I want you to think of it great or, which means union, all of both. And I'm trying to see if this is the one in your, I'm going to do a different one that's in your notes. I'm going to choose to do this one. So you might want to copy this one down. And I'm going to get rid of my solutions, so no looking. Come on, erase your work. Okay, so we want to graph B is greater than 2, or B is less than or equal to -3. Okay, remember they're married, so our solution is going to be everything in graph 1 and everything in graph 2. So here we go. B is greater than 2. So I'm going to draw all 3 number lines. Are you guys with me? Yes? Everybody doing okay? Alrighty, here we go. So I'm going to go -4, -3, -2, -1, 0, 1, 2, 3. Those are going to be my numbers. I line my graphs up because it makes life extremely easy to graph these. Okay, my first graph, B is greater than 2. What kind of a circle am I placing it to, Justin? And where's my graph going? To the left or right? There we go. Okay, my second graph is B is less than or equal to -3. What am I going to do there? Opened or closed circle on -3, class? Which way am I going, left or right? Left. Dun, 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 dun. Graph 1 and graph 2 are now going to get married. So my answer is going to include graph 1 plus graph 2, which means my answer will have an open circle at 2 to the right. Yes? A closed circle on negative 3 to the left. Okay? And my solution is B is less than or equal to negative 3, or B is greater than 2. So this one, in this particular case, because my graph is going in two opposite directions, I'm going to use the word or. Does that make sense? Hello? Okay, I do want to do the one in your notes, and then I'm going to end it there. So let me just go ahead and do it for you anyway. So this is the example from your notes. Yes?
This part, when I have or, do you still do without it?
Yes, I didn't put my boundaries on. Well, in this particular case, we really don't need the boundaries there, but yeah, you can put them. Actually, you should. Okay, because it gives you a visualization, so I'm sorry that I forgot that. So here we go. 2a plus 1 is less than 11. So the first thing we're going to do is I'm going to realize this is an or, which means it's a union, which means my answer is graph 1 plus graph 2. So I subtract 1 from each side. I get 2a is less than 10. I divide each side by 2. So my first one is a is less than 5. Does that make sense? Okay, my second one is a is greater than 3a plus 2. Subtract 3a from each side, and you get negative 2a is greater than 2. Divide by negative 2. Flip the inequality symbol, and you get a is less than, get rid of this. A is less than negative 1. Is everyone with me? Okay, so now let's graph them both. A is less than 5. Okay, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Less than 5. Opened or closed circle on 5. Which way am I going, left or right? Okay. The next one is a is less than negative 1. Opened or closed circle on negative 1. And which way am I going? Left. And so now my solution is my number line. Graph 1 and graph 2 are getting married. So graph 1 has an open circle at 5, but graph 2 doesn't. But because Mr. and Mrs. Urso got married, I now owned all of his sports equipment and everything else that he had in his kitchen, and he had to deal with all my clothes overtaking his closet. But now it became all of our stuff. So my solution will have an open circle at 5. And it will include everything to the left. But Mrs. Urso, the second graph has an open circle at negative 1. I know. But the first graph included negative 1 in the solution. So it has to be part of the solution. So your answer will be an open circle at positive 5 and everything to the left. But why? Well, at negative 1, Mr. Urso had a bag with 5 basketballs. Mrs. Urso didn't have any, but we are now married and live in the same house. Guess what? I own 5 basketballs whether I wanted them or not. Does that make sense? Do you see what your solution looks like? Yes? And now to write this in set builder notation, this is an extremely easy one to write. Who could write it for me? What would it be? Come on, be bold, be brave. Thank you. You got it, baby. A is less than 5. And I'm going to take all your questions in 1 minute. So let's just